Welcome to question 8 of the 2009 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So let f be the function e to the power of x plus k with the domain of the real number system, where k is a real number. The tangent to the graph of f at the point where x equals a passes through the point 0, 0. And we're asked to find the value of k in terms of a. So not that it's necessary to do this to answer the question, but we're going to start by drawing a simple graph to set up this problem. So the plus k is a translation. Technically it could be up or down, and I think it's going to be a translation in the positive y direction, and you'll see why I think that in a moment. So that's going to be y equals k, and then e to the power of x would be this graph here, so that's e to the power of x plus k. And then we know there's some tangent line that passes through the origin, so it has this point here 0, 0, and this point up here that would be at the point, if I just write up here, a, e to the power of a plus k. And that sets up most of the information we have for that question, so hopefully you can see now why I think k is probably a positive number. And now we need to do a few things to find k in terms of a. So the first thing we can do is look at the tangent line, and we can also work out what the gradient of that line is. So one way of calculating the gradient of the line is to calculate the derivative f dashed of x. And the derivative, as k is just a constant, it's simply going to be e to the power of x. Therefore, the gradient at a is f dashed of a, which is just e to the power of a. Now over on the graph, we'd already worked out 2 points that tangent line passed through. The first point it passes through is 0, 0. That's given to us in the question. And the second point that the graph passes through is a, and replacing x with a in our rule gave us the point we discussed before, which is e to the power of a plus k. So now what we've got is 2 points on that tangent line and the gradient of that tangent line. So we can work out how to equate those two things using m, which is the gradient of a straight line, is equal to y2 subtract y1 over x2 subtract x1. So 2 points that the graph goes through. So therefore, our gradient m is simply equal to e to the power of a. That's what the derivative evaluated at a will give us. So we can say e to the power of a is equal to the fraction y2, which is e to the power of a plus k, subtract y1, which is 0, all divided by x2, which is a, subtract x1, which is 0. And now all that would be left on that bottom line is a, so multiplying both sides by a, we'd find a e to the power of a is equal to e to the power of a plus k. And then to get k by itself, we're just going to subtract e to the power of a from both sides. So therefore we find that k is equal to a e to the power of a minus e to the power of a. So that is the answer to this question. So from the examiner's report, we can see just a fraction over a third of students managed to get that question right. And the solution that the examiner's report refers to is where we've equated the gradient of the tangent line to the gradient going through 2 points that lie on the tangent line. And that led to the answer that we got previously. Overall, even though a third of students were able to get the correct answer, it was still poorly done, with 42% of students getting no marks, and the question appeared to confuse many students on what they had to find. Common errors in the question included incorrect differentiation and using x equals 0 instead of x equals a to find the gradient of the tangent. Another incorrect error was stating that the tangent was y equals e to the power of x times x, whereas the tangent would have been y equals e to the power of a times x if you found the full equation for that line.